All right, here we go with week 4 of 8th grade science online learning. We're going to focus on chapter 5, which we should be review for most of us that we ended kind of our time before um, this coronavirus stuff hit and we had to do everything online. So some of this should be just review for you also. The periodic table, if we look at basically a little history behind it as we started off talking about, was first developed by Dmitry Mendeleev, and Mendeleev on the left there. He developed it and put them in according to atomic mass. So he looked at their masses and put them in order according to them. Still trying to put them in columns, things that were associated or grouped together. And then on the right is Henry Moseley, who was pretty much the scientist who is associated with developing the modern periodic table. It looked very similar to Mendeleev's, but he changed it and put it in increasing atomic number. So it's obviously the number of protons that are going to give us the order. Again, still putting them in columns of things that kind of matched up, had similar physical properties. So if we look at how the elements are arranged, one of the first things, the vertical column, as we just said, is called a group. Can also be called a family because they do have some of the same physical and chemical properties. When you look horizontally in rows, those are what are called periods. And period basically is standing for a repeating pattern. Periodicals or newspapers came the same all the time. So horizontally, anything in a period will show the same pattern going over and over and over again. So if you looked at one of them that are in the same group, they all have the same number of electrons in their outer shell. So if we look at beryllium, even though it's only got 2 shells, there's only 2 electrons in its outer shell. This is why we did Bohr models last week. Magnesium, it has 3 shells, but it still only has 2 electrons in its outer shell. So it's the number of valence electrons, those electrons in the outer shell, that give it the same physical and chemical properties. So as it says there, a number of outer valence electrons is going to cause how it bonds, and we'll get into all that stuff later. But it's the property of the element that are going to be all in the same group. If you go across a row and look at the period, what is similar about those is that they all have the same number of shells, energy levels, basically, as we look at the same number of circles that you put around a Bohr model. So if we were to look at one, potassium and iron in krypton, potassium up here at 19, and then we got iron at 26, and then we got krypton at the end at 36, all getting bigger, which means it has more electrons. But if you notice, they all have the same number of energy levels. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So they all have the same shells, but they don't have the same number of electrons in their outer shell because that comes from the columns. So you have groups or families in a column, and then you have rows that are periods. Now we want to focus in on what are some of the different properties of each of those columns or families, and there are some of them that we give names to. The first one is the alkali metals. It's the whole first column, group 1A up here as you go down. Notice we don't really include hydrogen with that. Hydrogen kind of is on its own. Acts as a non-metal and a non-metal, so it can be put in many different spots. But the rest of them, lithium, sodium, potassium, rubidium, cesium, and francium, all in the same column, all are soft, silver-colored metals that are very reactive. In fact, they don't really exist in nature by themselves. They react as soon as they come into contact with almost anything. That's why most of these react violently, explode. If you remember from our demonstration, we got out a little piece of sodium and it put it in water and it actually caught fire. So those are very reactive. Just water, oxygen is enough to cause them to react. Then in group 2, which is the second column, 2A, they use Roman numerals. Those are called the alkaline earth metals. Alkaline earth because many of these are found in rocks at the Earth's crust. So that's where the name earth comes from. Somewhat reactive, don't really exist by themselves, but are not nearly as reactive. They're not violent. More of a whitish color metal, but still silvery, still metals. But a lot of these are